communicative and something more interesting. But here, I'm not saying that it is not interesting, but usually, in general terms, we call it as a dry subject. Okay, a dry chapter, like your botany, like morphology in flowering plants or something like that. So, but it is quite not so right, because evolution is such a brilliant, such a beautiful chapter you can come across among all the chapters, I can say. Among all the chapters, this is one of the most interesting chapter you can just come across, because you would really, really take this concept so deep, and it will get you grounded. Okay, it will connect you to so many different things around you. You'll understand the nature, you'll understand the creation, and you will come to a doubt who created all these majestic things. Okay, so let's get started with our introduction. Okay, so in this chapter, basically, we'll be studying about how the origin of life happened, what are the evidences, theories of evolution, and what are the factors that affect the evolution, and a brief account on human evolution as well. Okay, but we'll try to touch as many topics as possible today, and then we will see. So when we talk about evolution, you can talk about this particular word. You can put it in every single aspect around you. You can tell that I have evolved myself in my work environment. I have evolved myself as a student. I have evolved myself as a family guy. Okay, so evolution is nothing but a gradual change. So you keep on accepting new things. You adapt to new environments and you new challenges and everything. So that is the word evolution means. But today we are talking about not just evolution, a specific type of an evolution where biology, evolutionary biology, we are going to talk. So, what is the reason why we have to study evolution? The reason is because it's a question: who put you here? And as a human being, we have this doubt: are we the only organisms who are thinking so much? Or are we the only organisms who is looking for the meaning of life? When you search for the meaning of life, you start looking at who created life or why the life was created the way it is today. So these questions come generally for every single human being. And the answers for this is many. Some say that God is the one that created the life on earth and the universe itself, and it is impossible that it happened randomly. Some people argue that the life happened, okay, because of the abiotic things, and some say that it might be extraterrestrial in nature. Correct? No. So there are so many different reasons on why or how or where the life originated. But as our science students, we always look for the proof, or scientific reasoning, or any solid proof that can give us a very, very trustful ways to accept how the life came on earth. So here's a fascinating story about the origin of life. So first we have to go to the very planet that we live on, the earth. So what happened 20 billion years ago? We can see that there was a huge cosmic event, which is generally referred as a Big Bang theory. See, this particular theory, I'm not telling that it is 100% the way it has happened, but this particular hypothesis, let's say that they have suggested this is the way it could have happened, but there is no proper proof that the Big Bang theory has happened. But what does Big Bang theory say? So let's imagine that the whole of the universe that was existing, okay? So the matter, we can just call it as matter. So the matter was scattered. So somehow all this matter starts condensing. So when they start condensing and collapsing onto each other, they started becoming a giant charged body. So everything started crumbling into this center, and from this center, the it becomes so unstable. The crumbling and the collapsing within becomes so unstable that it starts exploding. So it was a single explosion that started the origin of universe. See, when we talk about Big Bang theory or the origin of universe, we have to see that with origin of universe, two things started. One is space, other one is time. So including the time that you see, time is acceptable because time began with the beginning of the universe. But the space, even the space that you see, the surrounding that you see, that anything that occupies something is called as space. Even the space started with the beginning of the Big Bang. What was before Big Bang, nobody could answer. What is after Big Bang, we can just trace around the events. So when it started from a point, from this point, the matter was so much, okay, the matter was so much in volume. Whatever you see, the stars in your galaxy, to the planets, to the asteroids, to the millions of galaxies across the universe, and the vastness of the universe, you can't even comprehend with your mind the amount of space, the amount of matter, and the amount of what do you tell, the distance this particular universe occupies. It is not easily possible for us to imagine with our head. So that is the that is the width and that is the volume of the universe we are talking about. So anyways, so once this Big Bang theory, a Big Bang happened, now all the cosmic matter started scattering across this universe, and we also started getting our own place in our Milky Way. So you can see that in our Milky Way, there's a small spot where our solar system occupies. So at this spot, what happened? We have our giant ball, that is our sun, and whatever the objects that came out of the resultant of this Big Bang and the further explosions, you have these small cosmic objects like planets and moons and their moons. All of them, they started occupying their respective positions across the sun. And why did they occupy their respective positions across the sun? Because sun was a heavier object compared to that of any other object in our solar system. So this is how the gravity works. The heavier the object, they control the gravity around them. Correct? No. So the sun was so heavy, the Earth started at following the sun's gravity. So that is why our Earth revolves around the sun. Similarly, Earth has more mass, okay, compared to that of the moon, and it is closer to the Earth. That is why the moon revolves around the Earth. Okay, so this is a simple gravitational lesson that we already know. But the possibility that this is the sun and this is the Earth, and the Earth is at the exact perfect distance where we receive, equivalent or very nurturing, very what do you tell, warm, a very pleasant amount of light. Okay, we receive a very pleasant amount of light, and the gravity on Earth is not too light or not too high. That is one thing. The electromagnetic field that the Earth provides is so good for your body conductivity system. Okay, even one factor fails in this, nothing can exist. A little bit of gravity, everything would collapse into sun. A little bit of loose gravity, Earth would float away from the sun. A little bit of light electromagnetism that our Earth has, our blood will not circulate properly. Okay, if the moon goes missing, all our reproductive cycles will stop. You see, there is a huge coincidence that happened with the origin of universe and how we are placed exactly at the position that we are from the sun, etc., etc. But when you see, once you have a sun and the Earth was placed, Earth is not how we see today. Earth was a giant ball of fire, so it was just there. And what happened as the Earth started taking its position in our solar system, it took so many billion years for our Earth to really cool itself. You understand this point, right? From a hot ball of fire, a lava, it's like a molten, okay, and you can see it's not even solid, it's molten ball just floating in the space. It had to cool down for several billion years. So after that, what happened? It started solidifying. So now what happened? The Earth was around 4.5 billion years ago, it formed. And now, as I told, there was no atmosphere and Earth was completely non-hospitable. The temperatures were over 10,000 degrees Celsius, I can tell. Okay. So this was our Earth. So now what happened? Now Earth contained certain molecules. Exactly, yeah. The Earth contains certain elements. See, when the temperature is so high, you can't expect the formation of bonds, correct, right, between the molecules. So as the Earth started cooling down, the atoms came together, miraculous atoms. This was not random. I mean, like it's random, but it somehow became a huge advantage for what the Earth is going to become next. So once these molecules started condensing, I mean, like elements or atoms started condensing, they start making these bonds. And through these bonds, what happened is there was water. The first time the water vapor was created. and methane, CH4, carbon dioxide, and ammonia, they were the only initial or primary elements that were present on Earth. Okay, they were found. Now you see, uh, this is so magical that you have water, and when the UV rays, which was very harsh, we didn't have ozone back then. Okay, we'll come to the story how the ozone layer also formed. So through this UV light that was like completely harsh, you have no idea the amount of radiation that we receive on a daily basis. So in the absence of UV, in the absence of ozone, we would really kill ourselves because of the amount of radiation we would get from the sun. But the nowadays, I mean, like, the ozone has been protecting us from a very long time, but back then there was no ozone. So now what happened? The UV light that was coming, it started splitting again the water into hydrogen gas and oxygen. So oxygen was there. You see, the amount of oxygen that was present was very, very, very low. But whatever it was there, it started combining with ammonia, it started combining with methane, okay, and it started forming water and carbon dioxide, etc. Okay. Now, through this oxygen that was released, O2 combined with O and started forming ozone. Okay, O3. So, ozone was very, very important because the radiation is very harsh, and then it is not okay for the life to be formed. Somehow, the ozone started forming. Now, the earth started cooling. And when the earth started cooling, you see all the water molecule that was formed by the combination of H2O, it started condensing. You see, it started condensing. Once it started condensing, what happened? You can expect that once the condensation process starts, a huge amount of rainfall started occurring. And this rainfall was no joke. Hold on. Yeah, exactly. It started raining. And the raining was not for a day, it was not for a month, it was not for a year. It started raining for some millions of years. Okay, the rain was for some millions of years. So if you want to assume, if you want to just imagine how much it would have rained, just look at the ocean. Just look at the amount of water that is occupied by the seas and the oceans that you see. Correct, right? So all this water, when did it accumulate? It accumulated during the initial periods of the Earth, or the organic Earth formation, I can tell. So this amount of rainfall, it is not just rainfall. They say that for every second, around 200 times it used to strike lightning at the, not 200 times, around 72 times, something like that. It's somewhere around. The numbers is very high, but every second it used to start lightning. There used to be so much lightning. The entire atmosphere was so highly conductive. Okay, it started lightning and everything was raining. It was tsunamis and tsunamis of rainfall, so it started becoming oceans. So once the water started becoming accumulating in such volumes, now you can see that the earth has totally cooled down and the water has occupied 98% of the earth's surface. So there was no land at all. Majority of the earth was completely covered by water. So that is the amount of rainfall we expected. Okay. But they say, what I say that is the ocean is the mother of all. So she's the mother, and that is where the birth started. Okay, the birth of life or the origin of life really started. Okay, so they say that almost around some billions of years ago, the life originated. See, I will come across how the origin of life or how the evolution of life took place once we start talking about theory of chemical evolution, and from there we start to kick back on how different organisms evolved at different time frames and everything. Okay, so this is a very rough and very generic, very generic idea of how the earth formed and what was the condition and how did the life took to, how did the conditions were there. The more we read, the more we come across, it is so unbelievable and it is so cinematic to even imagine the story of earth. Okay, but let's come to the modern days. In the modern days, what happened once we were searching for the proof, and the once we were searching for the meaning of life. See, I can't just tell that only during the 17th century, only during the 16th century, or in the 15th century, humans really started realizing, okay, this is science, this is mathematics, this is arithmetics, etc., etc. But this is very, very false. Why? Because If you just look at our own country and our own culture, and if you trace back how our people believed, our people really had a large amount of knowledge and wisdom on the origin of life, on where the life would have started, on how what is the expanse of the universe, and what is the controls of the universe, the amount of planets that are present. Without any modern equipment, we had all these things, but in a very classical and very religious forms. So that is where we could not be highlighted in the history of education, especially our cultures. But fortunately or unfortunately, there is a documented and well accepted theories and discussions that happened in the Europe. So that is why we follow most of the European way of belief system and their ways of evolution with understanding things. But all these things were far, far away, discussed and clarified, and we had come to a common understanding. But anyways, these Europeans, that is where they started their own theories. So now what happened? Once the discussions of how the origin of life took place, how the evolution took place, and all those things was happening in the West. So the majority of the thoughts and majority of the ideology that the people in the society had was controlled by church. So for anybody who would say, who would go and say that, see, the life, for example, we have our Mendel, right? So Mendel was telling that there was some factors, and the factors are responsible for transfer of characters, and they have this, properties of dominance, their recessiveness, or anything, whatever he was saying. They thought he is mad because above everybody, God is there, and He created everything. So going against the church was not such a easy job. Yeah, and any religion, going against religion was not an easy job back then, and it was not so easily accepted. But some of the brave people just really went and proposed their idea on how the life originated. Among them, these were the initial theories, and one of them is theory of abiogenesis, theory of biogenesis, theory of panspermia, theory of creationism, and then you have theory of chemical evolution. We can see here how the idea of evolution began according to them. So first we talk about theory of spontaneous generation. So the theory of spontaneous generation, what you have is, it says that, or it is also called as abiogenesis. Abiogenesis means it says that the life originated from the pre-existing life. Okay. So abiogenesis is actually, it says that through death the life arises, or through inorganic materials the life originated. Okay. Here it is given. Okay. That Louis Pasteur disproved the abiogenesis theory, but we will understand what is abiogenesis. A means no, bio means life, genesis means formation. So abiogenesis is formation of life from abiotic factors like air, water, and soil, etc. So now what happened? Some people would bring what do you tell? Killed yeast, and through that they could see the mold developing. Okay, or they could see that the meat which is already from the dead animal. Okay, it dead, right? And then you could see that the from the dead the maggots would arise. So that is where the people would tell that, see, when it is something is dead, a new life arises from that. Okay, so that is why through decaying and rotting matter like straw and mud, there would be some life coming out of it. So people thought that, so something died, and through that the life originated. So that is when the abiogenesis theory was suggested. But now what happened? Theory of biogenesis. Here comes the Louis Pasteur. So Louis Pasteur was very much famous for his, scientific method of sterilization. You see, he taught us how to sterilize milk and how to sterilize our medical instruments so that we have aseptic conditions. But anyways, he was very famous. Now, what he told that Louis Pasteur tried to disprove the abiogenesis theory. So he said that it is not really true that through death the life originates. Okay, so he said that for the life to originate, you need biogenesis from the previous life, or from the life originates life. So that is what he says. Life originates from the pre-existing life. So when Louis Pasteur told that life exists from, or originates from the pre-existing life, he could not prove when was the first life, or how did the first life arise from the planet. So that is where he failed to prove or give more explanation to his theory. But anyways, biogenesis was also completely false, and it was not accepted widely. And then comes the cosmic theory. So the cosmic theory, I'm not telling that this is a theory where people just disproved and then it was just tossed away. Even today, including me, I believe that the life really, some of the life, I'm not telling the all of life, some of the life really come from extraterrestrial source. Okay. So life was not completely originated or organic through Earth, but something, influenced from the outside for the life to come on our planet. Okay. So cosmic theory, the amount of theories, the amount of ideas, or the amount of ways the life could even begin here is exaggerating. You can tell, you yourself can tell. So let's imagine that there is an asteroid, and this asteroid is from a planet where it was very rich in life. Somehow this asteroid had some spores or some remnants of these microorganisms, and somehow it traveled through the space and time, and then it collapsed on the Earth. So when it collapsed on the Earth, Earth's conditions were very similar or very good, more good than compared to that of their planet. And now, could it originate on this Earth? Definitely yes, it's possible. Okay, so what is cosmic theory? Cosmic theory or theory of panspermia, it states that some of the units of life or the spores were traveled from extraterrestrial source, not on Earth, but from extraterrestrial source. I believe that we are aliens. Okay, humans are aliens, and no other organisms. I'm telling that they are not belonging to Earth. We don't belong to Earth. Do you agree with me, Shane? So you see, all animals and all the organisms that you see, they are so much involved with each other. They are so much ecologically balanced. Correct, no? But if you see human beings, we don't actually interact much with our environment. We are completely isolated, and moreover, you can see that we are the highest infected organisms on the planet. We get so many diseases compared to any other organism. Okay, and all the organisms have different. For example, you have polar bear and brown bear. You can see the difference. The polar bear lives in the ice. The brown bear lives in the forest. You can see the skin color. You can see the adaptations, and you can see how different they are. But you see human beings, yeah, we are same from Antarctica to Africa, from Africa to India, from India to everywhere, America, everywhere we are the same. We are the same human beings except for the skin color, right? So we are aliens. So that's why I believe that we are the panspermia. We are the ones that come from the extraterrestrial. This is my idea. Okay, so not our my idea. Many people believe this. Um, so cosmic theory is interesting, kind of interesting. So it's nice. So then comes theory of special creation. Now, the thing is, if you just observe the vastness of universe, and if you see the amount of time it would take, and the amount of what are the chances, man? What are the chances that we are the only people on this solar system, and we have not found life even today? Even today, we haven't found a single life, a single cell, or even a single molecule that would give us the idea that this there might be life existed or existing or might exist. So that belief or that proof or that I've never come across this. Just sitting like ducks in this whole empty universe and only us being there is crazy. So seeing the chances of us being formed or created is something spiritual and something which you might question science sometimes. Even I would question: is it possible that everything happened randomly, and through randomness that we are born? It is crazy. Why? Because we are the only people who are so conscious and who are connected to God, who are connected to science, and who are fighting between these two. Correct, right? No other organism has to take this headache, but we have the headache. And through that headache comes two possibilities. What is that? Are we the only organisms in this universe? Or this is also a scary thought, correct? No? If you think that we are only the animal or the only planet where the life exists and nowhere else, is very scary. That means you are alone. And if there is also, if you think that okay, we are not alone, somebody else is there, and that is not such a friendly thought. It's more scary. Why? Because if their technology is more high than you, if they're more advanced than you are screwed. Correct, right? So there will be Independence Day. All the aliens would come and destroy you. So the Hollywood movie would be real. So that is a thought. And seeing all this and observing all this, what would you think? God is there. Okay, so literally, if you just see and if you just read some of the text of our culture, we just didn't talk about one universe. In Hindu text, we can see really they don't just talk about one universe. They say that there are multiple universes. There are some texts that says there are multiverse theories and how the universe created, how the universe would end. All that is so specifically given. Okay, but anyways, many cultures, like you take any cultures from any country and any part of the world, they always come to a point of something like very supernatural and something beyond human, something very more powerful existed or existing, and these control all the factors that is happening in the universe. Somehow believable, somehow you after all the science fails and your brain really stops at a brick. What do you think? You should just really say like, it's impossible, mate. So something would have really helped us, or something would have really designed these things to happen this way. So that is when the God comes. But the problem is, uh, you know, I can't say that all the texts are like completely not really rational. Some are really rational. Some give really good explanation, acceptable explanation. But generally, what idea was eliminated? I'll tell you. So theory of special creation or theory of God. Okay. So where it got completely rejected was, so they thought that the cultural text said that all the life that you see on earth created as it is. Okay, that is where it fails. I'm not telling that all the cultures said the same thing. So some of the cultures, they believe that all the life on earth was created as it is. And for example, you take a tiger and you start killing a tiger, and tiger would not go extinct according to them. So God created it and God would sustain it. So you are there, you are meant to exploit it. So you are also the creation of God. They are also creation of God, and it would stay for like that forever. So that is the idea that completely got this particular subject rejected out of the scientific society. But now we are realizing not all societies thought the same way. What about dinosaurs? So dinosaurs, they were the victims of a very unnatural event that occurred long back. So dinosaurs were like a completely, what do you say? Let's say, see what happened. You think that asteroid strike or any object that would collide from the Earth would be a small event. It is not actually. So the asteroid that come and hit the Earth when the dinosaurs existed, it is not a small asteroid. You see, this particular object would travel into several thousands of miles per minute. The amount of speed would be like 60,000 miles per second or something like that. So they're very fast. Huh? So they would come at this speed, and even if it is a small stone, the impact would be very high. With the amount of speed, with the amount of mass they carry, if they collide even on such a big surface like an Earth, it might not shake the Earth. The Earth shook actually. So it might not completely break the Earth into two. But what happens here? The collision creates a large catastrophic events. So what kind of an event? The impact created a huge dust. Okay. See, explosion happens. So the explosion, what happens? There would be dust and debris. Correct? No, there would be a lot of dust and debris. So this dust and debris was so much created. Okay, and through that there were volcanic eruptions. Earth was not still stable. Okay, there was the cosmic, seismic events that was happening. So once this all this dust started accumulating, it became a giant cloud across, blocking the sun to penetrate the Earth. So when the Earth was not able to receive the light, now the dinosaurs were devoid of the light. When they were devoid of the light, it starts getting really cold. So when it starts really getting cold, what happens? It starts freezing. So within just a span of few months, the Earth loses a lot of temperature. So animals, reptiles, they were. So when they were adapted to a certain temperature, what would happen? They cannot regulate their body heat, right? So with the impact of the asteroid, the amount of dinosaurs that died is very less. But after the effect of this impact, now the amount of dinosaurs we lost was way too high. Okay, I'm not telling all of them died, but many of them evolved into next life. Actually, like you see the chicken that you eat, It's a very closest relative of the dinosaur. Yeah, you see. So that's one thing. And next comes your the theory of chemical evolution. So this is a most brilliant and the most orchestrated theory that Oppenheimer and Haldane proposed. So why would I say that? See, even before studying the evolution, I would feel that this is not something magical. The life or the cell could not be started just like boom, like a magic. It did not happen like that. So something very atomic, something very molecular should have assembled and should have formed the life. Even I would feel this many of the times before even having the idea of evolution. So that's what Oppenheimer and Haldane suggested. So what they said that is life on Earth that you see. See, when you trace the life on Earth, any organism you see, what is the last thing that you go across is a cell. Correct, no? But a cell would be the basic unit of the life. So starting from there, you cannot say that the cell as the beginning point. It's never the cell is the beginning point. So if you go back and back, what is the beginning material that we had on Earth? It is just organic substances. So somehow these organic substances they came across, okay, and they started becoming biomolecules. So if you see the conditions on the Earth back in the days when the first cell could be formed, and then you mimic these environments in your laboratory, what you would see is the formation of sugar, the formation of RNA molecules, the formation of lipids or the nucleic acids in an artificial condition where there is no life at all. So these are the key molecules that run the life on planet. See, even in your cells, without nucleic acids, there is no genetics. Without sugars, there is no energy. Without proteins, there is no, biological framework. So all this started forming from the inorganic or the abiotic substances, like your ammonia, like your water, like your methane. So they interacted and first started, forming biomolecules. And somehow these biomolecules starts coming together and they start forming an isolated system where they could interact with each other and function as one system. And this system is the beginning of the formation of cell. So it's a brilliant theory that Oppenheimer and Haldane suggested that there's a possibility that the life started, and the life did not start just by a cell. It started with the excuse me, yeah, it started by the formation of inorganic substances, and these inorganic substances came and became an inorganic and organic substances. They started coming together and forming a unit, and that is where the first so-called cell might have arisen. And once this isolated system starts becoming more and more aware, more and more functional, then a consciousness evolved as it is. So first was abiogenesis. That's the life started from inorganic substances and organic substances, okay, like the chemicals. And then through that, the biological life was evolved. So it's a very, very brilliant, very, very well thought, and very acceptable theory was suggested by Oprin and Haldane. But Oprin and Haldane, they could not prove their theory through any of what do you tell experimentation. Got it? No? Are you able to follow, Shaheen? Yeah. So which JNV are you from? Yeah. Which JNV? Like which school? Oh, you're from Kadapa. Telugu. Yeah. Cool. Yeah, chalo. So next comes Miller's experiment, Urey Miller's experiment. Urey and Miller are two different people, and many of us get confused. Yeah. So that they are one people. So you have Harold Urey and Stanley Miller. So they started experimenting, and their experiments were. I'm from Bangalore. Yeah. So their experiments were to just prove that the theory of chemical evolution was right. So the idea was started like, okay, we just try to create the earth conditions where we could think that the life originated, and create this, a system. Okay, let's imagine that we are trying to create a system that mimics the earth's condition way back in time, something like around 2 billion years ago. Okay, so 2 billion years ago, it was thought that earth had a certain condition. Okay, the theory was the earth was 700-degree Celsius, and there were like basic elements like ammonia, methane, water, hydrogen, etc. And there was like a lot of electrical conductivity in the sky. So we put an electric discharge, okay, and the earth was continuously condensing, and then there was rainfall. So that is why they created these conditions. Okay. And their idea was to whether prove or disprove the chemical evolution. But the outcome of this experiment was brilliant. So what is that they created? See, first what they did was, so they created this reactive flask where you have a primitive earth conditions. What is a primitive earth condition? So back then, okay, where the life started evolving 2 billion years ago, life started. Okay, if you go back there was like very high temperature. How much of the temperature are they expecting? Around 700 degrees Celsius of temperature. There was like a lot of volcanic storms and reducing atmosphere. As I told you, when what is reducing atmosphere? Everything is condensing, everything is cooling. So there are like a lot of elements and a lot of condensation happening, and new elements are forming on a daily basis. Okay, so that is what is called as reducing atmosphere. And what was present in the atmosphere? There were like very rich methane, ammonia, water, hydrogen, etc. Okay. So, and they also created an electric discharge. It was a completely closed flask, completely isolated, completely vacuum. Okay. See, they have put it 800 degrees Celsius. Okay. And there was like constantly water vapor was provided. So what happened after this is I need the proper picture of this to explain. Okay. I hope you can see here. See, here the water is boiled, and after the water is boiled, now what happened? The vaporization happens, and here as it moves up, it has to the slowly it has to become condensed. Here is the electric discharge, so the condensed water would accumulate like the rainfall. Correct? No, here it is a rainfall, and all the water that is coming as a rain, it comes as a droplets and becomes a sea. So this is our oceans. Okay, imagine that this is our ocean. Now what is happening here? In this atmosphere, this is where all the electrical activity and the condensation process takes place, and it mixes with our inorganic gases like ammonia, methane, water vapor, and hydrogen. So once it reacts here, along with the water, it has come and accumulated here. So when they tested this water, okay, when they tested this water after some time, what did they see is they saw that there was the formation of amino acids. Actually, the Stanley and Uri Miller, they started RNA. Their first molecule they saw was the formation of RNA, sugar, and lipids, and pigments. Okay, so they could see that these molecules were forming or they were found in this accumulated water. So other people got very curious when they said that, see, guys, when we just did an experiment and we didn't give any of the cells, there was nothing, but we saw the formation of amino acids. And these guys said, we saw the formation of RNA. And others really jumped into this experiment and they started conducting their own. When they did, there was like sugars, there was nitrogenous bases, pigments, lipids, fats, etc. Okay? How so? Yeah, that is a thing. See, what happens is when you see what is your amino acid, you have a carbon. That's why we call carbon as the most beautiful atom that was ever created, because we are all carbon based organisms. So methane is there, Baba. So what is methane? CH4. So this is your CH4. Correct? No. Now for the formation of amino acids, what you need is the first is a functional group. Anything could be a functional, a OH, a CH, or anything could be a functional group. Anything. Okay. Or what do you need here? Here you need an amino group. It might be NH2. Okay. NH2 or NH3 would be your amino group. Okay. And then you need your acid group. So you would remove one more hydrogen atom and put another carbon or acidic form of carbon. This is nothing but your amino acid. You understand my point? Yeah. See, what is required for the formation of RNA? Again, we are carbon based. Okay. There is a clear chance that the permutations and combination of the elements can happen, and that would lead to the formation of organic substances. You see the vastness of the earth, you see the volume of the reactions that is taking place, and there is a very clear chance where different things happen very simultaneously, right? This is just a flask, one flask experiment with a very small volume and a very small environment. And there we could see the formation of sugar. What is sugar? Sugar is again the combination of carbon, hydrogen, and oxygen. For example, C6H12O6. It's a glucose. It's a combination of three these things. Again, if you go to the formation of lipids, what is lipids made up of? Lipids is or fats. What is it made up of? Fats, you can see that it is made up of a fatty acid chain. What is a fatty acid chain? It is a chain of carbon atoms along with some hydrogens. So these are nothing but fatty acid chain. And what is it combined with? A glycerol molecule. What is glycerol molecule made up of? It is made up of three carbon atoms, and it is having four hydrogens, and the rest of it is OH. So it's always again carbon, hydrogen, and oxygen. Again, it is carbon, hydrogen, and oxygen. So when you have a preliminary material like methane, ammonia, and water, anything could happen. So because all of us are these based organisms, which are those? One is the nitrogen, one is the oxygen, one is the hydrogen, other one is the carbon. They rule your body, or they rule the life. Okay, so these elements were already present, and you could expect the reactions would lead to the formation of such organic substances, and that is when you could see the formation of sugars, nitrogenous bases, pigments, and fats. Okay, is it clear? Yeah. See, yeah, what happened is two important things that matter now is one is pigment, not two. Everybody played a role. Every single biomolecule or every single magical molecules we can call, like your lipids or fats or the nucleic acids or the sugars, or you can also see proteins or amino acids. Everything had a role on its own. Now, what happened? The ocean was a soup. I call it as a soup. And this oceanic soup contained rich life-giving molecules, such as one RNA molecule that you could see was not just like invisible. You can just imagine that it would be as long as 2 kilometers in distance. Very, very huge chain of RNA molecules, very, very huge chain of lipid molecules, very, very huge chain of sugar molecules. So we are not talking about small cell with all these things. We are talking about the soup filled with this. Okay. So now what happened? Let's imagine there was RNA. Here it is. Okay. There is RNA, there is pigments. Okay. And there is sugar. All of them, they are here. And lipid has a character. So the lipid started making an envelope. And what type of a liquid it is? Lipid. For our convenience, all life on Earth is made up of a specific type of a lipid, and this is called as a phospholipid. So what is a phospholipid? Your plasma membrane. Okay, plasma membrane. So if you observe the plasma membrane of a bacteria to the human being, all of us have a similar type of a plasma membrane, which is made up of lipids and proteins. You see that? So what is the role of plasma membrane? Plasma membrane actually has two, it's very simple, guys. You just put a phospholipid in water. What happens is there is no life. Okay, just take a phospholipid, put it in water. I need some space. Where is the space? Hold on. Yeah, let me write it here only. I hope you can see here. See what happens. You can see that this is a head. Okay, imagine that this is a head and this is a tail. And this tail is a fatty acid tail. Okay, I'll tell that it is a fatty acid tail. A phospholipid, no. So it will be made up of fatty acids and a phosphate head. The P head or the phosphate that is present in this phospholipid is water interacting. It interacts with water. Whereas the fatty acid tail, okay, hold on. Yeah, hydrophobic tail. Exactly. You have a hydrophilic head and a hydrophobic tail. Correct, right? So the moment I drop it in water, what they do is all the water interacting heads will point towards the outside like this. It's called a mesial formation. So they do this and then they project their tails towards the inside. That means all the hydrophobic or the water part will be put in inside, whereas all the water fighting, I mean like water loving, which is the hydrophilic, will be towards the outside. This is their nature. So when you have two lipids coming together, all the heads started going out, all the heads started going inside. Within this, what happened? The tails were hiding. So this started forming a lipid bilayer. So this lipid bilayer was no ordinary layer. It was able to interact with its environment. That means it allowed only what it wants inside and it sent what it only required to the outside. So it formed a really interacting barrier. Once this was formed, all these molecules that was there, they were not quiet. Okay, they were not quiet. The lipid, the pigments, they started receiving the sunlight, and somehow they could use this sunlight energy to use the chemical compounds that they are there. See, either two ways in which the energy could be given to a system. We need energy to run a system. What is that energy? Either you get from the sun or you get from the chemicals. Your autotroph. Either you are a photoautotroph or you are a chemoautotroph. If you are a photoautotroph, you take the sunlight, you break the water and oxygen into two, hydrogen and oxygen, and then you try use these electrons. You take these electrons and try making some ATP out of it. Correct? Or if you are a chemoautotroph, for example, if you have sulfuric acid in the water, or if you have nitric acid in the water, you start breaking these compounds. With the breakage of these compounds, what do you get? You get a lot of energy. And this energy is again pushed in the form of an electric, in what you tell, when you break it, the electrons are released. So the electron transport chain is created for the formation of electrons, for the formation of ATP. See, somehow these pigments were started conducting, breaking and making process, and there was like a lot of energy that was released. And some, after the, it's a long process. As it move ahead, they created the currencies of energy molecules like ATP. And with this conduction system, one of the organism, I can tell, mitochondria was not an organelle. It was a completely different organism. Okay. So it mastered the technique of producing ATP. So whatever the electrons that was released by this pigment, it could really channelize and make ATP molecules. So this is an energy house of the cell. So they started integrating into your, cell. The mitochondria came from outside to inside. The chloroplast, which is again the outside organism, came from outside to inside. That is why you can see that mitochondria and chloroplast, they both have their own DNA. They both have their own ribosomes. So they are called as semi-autonomous organelles. That means they can live on their own without the help of their cell. They go on their own division. They are completely independent. They monitor themselves. The reason is they are not there from the origin of cell. They are completely different cells. So it's a symbiotic association that you can see at the organelle level. Okay, so they both started integrating. Now you have energy and you have the light harvesting system. Now what happens to this RNA? This RNA had some characteristics like it could completely give character. I mean, like it could control the activities. It would synthesize proteins, and these proteins would carry messages from. You see, it's a complex system. A cell, as it looks so simple, it is a complex, self-operating, self-conscious, self-replicating, self-repairing system. You see, so that system was created. So that is the earliest form of cells. You see, where you have just a bubble, and within the bubble, all your biomolecules like RNA, lipids, sugar, all of them started accumulating. And this happened around 3 billion years ago. Until 2 billion years, the cell was not formed. A real practical cell was not formed. You see, so that is when the life started. Uh, we stopped back then at a point where the oceans were created. And I told you that we would continue further. And this is the continuation of where the oceans were like these, and Uri Miller's experiment gave us an evidence that there could be the formation of these special molecules and how these special molecules accumulated and they could start the process of life. Okay, but guess what? They could really trace until the formation of this isolated system and all the pigments and sugars and all of them accumulated. But we are yet to see the beginning of consciousness, the cell acting on its own. We have not come to that stage, and no evidence is still there. Okay. Anyways, thank you, Shaheen, for being very patient. And we can start with the evidences of evolution in the next class. Probably in another 1 or 2 classes, we'll be finishing evolution. We're going to fast forward this, the process. Okay. And hold on, before you leave, please do me a favor. Please try to answer this poll. Yeah. My name is Vinay and I'm from Bangalore. And నాకు బాగా తెలుగు వచ్చు. Yeah. Yeah, 1 second. Yeah. Yeah. చాలా బాగా వచ్చు నాకు. I love Telugu movies. I love Telugu literature. Yeah. I really like the language. It's the most poetic language that you can ever come across. All right. Thank you. Thank you for the feedback, Shaheen. And I hope to see you in the next class and we'll share more knowledge with each other. And if you have any doubts in any other topics, you can please be very free and ask me. All right. Uh, Anyways, have fun. Have a nice day. See you soon. Yeah, yeah, definitely. Me too. Me too. We'll discuss some, some crazy subjects. I'll bring on more information. Since we are like lack of time, it gives us a restriction that to finish topics very soon. If it was a real class, trust me, we would have a journey on so many things, right? So, anyways, we will make as much productive as possible in each session and enjoy, as a curious science students rather than stuffing information in our heads. All right. All right. Thank you. Have a nice day. Bye bye.